All right, today we're going to introduce two new topics, still moving through section 10.1. We're on page 218 in your book if you want to follow along. Today we're looking at speed and velocity, okay? When most people talk about speed and velocity, they use these words together, right? They pretty much mean the same thing, but when you're talking science, they have a minor difference, right? We are talking essentially about distance over time, okay? How far you go and how long it takes you to go, okay? So that is the definition for speed. All right, just simply the distance over the time, okay? How far you go and how long it takes you to get there. T is kind of hard to see, so I'll write time in there. All right, distance divided by time, that's miles per hour or feet per second, however you've heard it. That is speed. All right, the difference with velocity, we are adding a vector. We're adding a direction or we're adding some sort of change in vectors with velocity. Okay, so it can also be measured in distance over time, right? That's still the essential unit, but it is more specifically displacement over time, where you got to over time, how far from your starting point you moved in a certain period of time. All right? All right, so let's try to break these down into formulas. We said speed is distance over time. We said velocity is displacement over time. All right, so let's say we make velocity v. All right, so velocity is v. All right, and what did we just say v equaled? All right, displacement over time. All right, so displacement, what is displacement? That is change in distance, okay? I'm just going to put delta x for change in distance. Delta means change, and we put an x there just to give some sort of value. Okay, so change in x, change in distance is what we're talking about. That will give us displacement divided by time. All right. If you wanted a formula for speed, all right, speed we'll say is s, and s is equal to distance divided by time. Speed equals d over t. It's kind of hard to see on there. Speed, s, equals d over t. Speed equals distance over time. All right. All right, let's try an example for each of these so you guys have a way of seeing it. And cut. All right, so let's try an example for each of these. For speed, all right, let's say that a plane, all right, travels 900 kilometers in 1 hour. All right, so 900 kilometers, 900 km, and it took them 1 hour. All right, 900 kilometers in 1 hour. What's the speed? Well, it is 900 divided by 1. That's 900 kilometers per hour. Okay. Let's say it was 2. So let's say it took them 2 hours to go that far. All right. 900 over 2. So divide. Actually, put that in your calculator. Put 900 divided by 2. You will get 450 over 1 hour. So 450 kilometers per hour. All right. So whenever you divide or multiply in an equation like this, you do the same things to your units. Okay, so essentially this is kilometers per hour. All right, just like you would say miles per hour, this is just metric, kilometers per hour. Whatever you do to your numbers, you also do to your units. All right? Okay. And cut. All right, so when we start adding vectors, we start adding displacement into this equation. All right, let's say that same plane under the same power is going 900 kilometers per hour. All right, and it's going straight east. All right, straight east. 900 kilometers per hour straight east. But there is a wind of 10 kilometers per hour going back west. All right, 10 kilometer per hour wind going back west. All right, well, the velocity or traveling, change in displacement over time of our plane is 900 this way, but it's being pushed back 10 that way. All right, so you can just add those up. In our case, technically subtract because they're going against each other. All right, so 900 minus 10 is 890. 890. We're thicken that up for you a little bit. Kilometers. All right. Per hour. All right, we just added those together. Technically, like I said, they're working against each other. They're opposites. So when we add, it was a negative or subtraction, however you want to see that. All right? And cut. All right. Very similar case. A very similar case to this. All right. But let's say that the wind is not going against you. All right. Let's say it's going with you. All right. So let's say that you were traveling in the same plane, 900 kilometers this way. All right. 900 kilometers per hour. And the wind was also going 10 kilometers per hour. All right, in the same direction. All right, if they're going in the same direction, what do? We add them together. All right, so this would be 910 kilometers per hour. All right. Another example is when it's not going against you or with you, it's going parallel, or it's going perpendicular to you. All right, so let's say that you are traveling this way. All righty. And the wind is traveling this way. All right. All right. Maybe you'll remember from our last video. If you don't remember, you can either ask me a question or go back and check out the last video. If there is a wind traveling this way and a wind traveling this way, or a speed traveling one way and something else traveling perpendicular, what do we create? All right. What do we create? I'll make it a little more obvious if I put them side by side right here. All right. What does this create? It creates a triangle, right? And so what we get is we get a vector going this direction, once again known as our resultant. Okay, we added our speed and the wind and got the actual direction of travel. Okay? All right, now let's look at how to calculate this. Okay, it is just how we did it in the last section. Okay, we use the Pythagorean theorem. All right, so a squared plus b squared equals c squared. All right, our hypotenuse, or our resultant in this case, the big line here, is our c squared. So we'll square whatever this number is, this number. If we were using the numbers from earlier, we'd square 900, add it to 10 times 10, we'd square the 10 there, and it would give us our resultant. Right? Take the square root of those numbers added together, get our resultant. A squared plus b squared equals c squared. All right, the next concept we're going to add is acceleration. All right, you've probably heard about acceleration in cars or roller coasters, but acceleration is the change in velocity over time. How fast does your car or vehicle or you speed up over time? Okay, so acceleration equals change, which is delta, in velocity over time. Okay? Change in velocity over time. All right? Delta V over T. A equals delta V over T. All right? If you don't remember, our delta V can be expanded to velocity. All right? Velocity final minus velocity initial over time. All right. Velocity final is what speed you end at. All right. Velocity initial is what velocity or speed you begin at. All right. All right. So most of the time, all right, acceleration is positive. All right. When you are speeding up, that is called accelerating. All right. When acceleration is negative, we call that decelerating or deceleration. Okay. So when you are stopping a car, when you put the brakes on your car, or when you run into something, when you run into a wall or a tree, whatever it may be, you decelerate, right? You change your velocity negatively over time. You're slowing down, coming to a stop. All right, let's try an example of acceleration, okay? And when we do this, we're going to also look at the units, because the units become a little interesting, a little tricky when you start dealing with acceleration, okay? So acceleration is velocity final minus velocity initial, or delta V. All right, divided by time. All right, so let's say we have a race car. All right, very good race car drawing here. All right, we have a race car. All right, and in 10 seconds, all right, it takes it 10 seconds all right, to get to 20 meters per second. All right, so its velocity is 20 meters per second, and it takes it 10 seconds to get to that speed. All right, so 10 seconds, that's our t for time. So I'm just going to write this over here. Acceleration equals 10 seconds. All right, what is our final velocity? What is the final speed of our race car? All right, we said it got to 20 meters per second. All right, so velocity final is 20 meters per second. All right, minus, I added the seconds there for the 10 seconds as well. All right, what is our initial velocity? All right, let's think about it. If it takes our car, we're talking about a race car, 10 seconds to get to this speed, what did it start from? All right, typically when you're talking about a race car and talking about speeding up, it started from 0. It was stopped, right? It was on the starting line. Okay, so our velocity initial is 0 meters per second. All right. All right, now this is a very easy number. You can plug it into your calculator and you will get 2, right? 20 minus 0 is 20, divided by 10, that is 2. Okay, so acceleration would equal 2. All right, but we need to know the units for that. Okay, if you remember, hopefully from some math somewhere, if not, we're learning it right now. When you add or subtract units that are the same, so meters per second and meters per second, that's fine. Okay, if I have 4 apples and I lose 2 apples, I have 2 apples. All right, there's no weird calculation that happens when you add or subtract. They're still the same thing. All right, we're still talking about meters per second. Okay, so we subtract that, we get meters per second. All right, minus 0, you can essentially get rid of that. All right, we have meters per second. All right, and we have second down here. Meters per second divided by second, all right, is the same as saying meters per second times second, all on the bottom down there. All right, MSS, okay. And seconds times seconds, all right, that's seconds squared. Anything times itself is that number squared. So the way we say it, all right, let's say we're talking about speed, it is typically meters per second squared, or feet per second squared. Whatever the time unit is on the bottom will be squared, okay? So like I said, you can have feet per second, you can have feet per minute. There are all sorts of different numbers that can go in here, different types of units. But the bottom number, the time unit, will be squared. So this is 2 meters per second squared. Acceleration, it accelerated 2 meters per second squared. All right, so every second it got 2 meters per second faster, is what that means. All right? If you have any questions, let me know. We are going to do the application on this section, and so I will point you to that in class.